Welcome to Train Signal. I'm Ross Bagurtis, and in this video we're going to be talking about Dynamic Host Configuration Protocol, or DHCP. Now, in every network environment where we're using IP, we have to assign an IP address to every single device in our network. Now, this little network that we have here, where there's 3 PCs, a printer, a router, and a server, we could probably do this manually. However, I've worked in environments that have 15,000 devices or more, and actually have a 15,000 device network in the grand scheme of things is actually relatively small. When you have 15,000 devices, the last thing you want to do is manually assign IP addresses to each and every device. Instead, what we want to do is have an automated way of handing out IP addresses to devices. So to do that, we use Dynamic Host Configuration Protocol. And what it does is it automatically configures all of the information that we need in order to get our PC to operate properly. So the way this works is that when we bring a PC onto a network that does not currently have an IP address configured, and the workstation is set to obtain its IP address automatically, what'll happen is it'll start sending out these DHCP discover messages. And the discover message is sent from the client that's trying to get an IP address, sent down to the network, and then if you noticed what happened here is once that message, that DHCP discover message hit the switch, it split up and went to every single device on the network. Well, there's only two cases where that can happen. Case one is when the switch doesn't know the MAC addresses of the devices that are connected. But in this particular case, every device on the network gets the message because a DHCP discover message uses all Fs in the destination MAC address field in the frame header. So because there's all Fs in the destination MAC address, all devices get it. The idea behind this is when a device comes onto the network and it doesn't have an IP address and it doesn't know where to get an IP address, it just sends a message out to everybody saying, hey, is there somebody out there that could please give me an IP address? In which case, all the devices will disregard their messages except for the DHCP server. The DHCP server will then create an offer for the client requesting the address. And here it's giving it an offer of 192.168.10.18 with a mask of 255.255.255.0. The gateway address 192.168.10.1, that's going to be the IP address assigned to the router up here. That's our default gateway. DNS of 8.8.8.8, that's Google's public DNS server. And then it's going to offer a lease time. So DHCP server is kind of like a property manager in that he leases the property of IP addresses to clients for a fixed period of time. In this case, it's 86,400 seconds. And if you want to do the math really quick in your head, that's 24 hours. So what this means is that the DHCP server is offering the client this address for 24 hours. So it sends that offer over to the client. The client reads it, records the information in it, and then it sends back a request for that particular IP address. So it says, yeah, this address is fine, I accept it. So now the DHCP server will permanently add it to its log, and then it will send an acknowledgement back to the workstation saying, yep, I've received and recorded that you want IP address 192.168.10.18 for the period of 24 hours. Now that lease time, how that's used is dependent upon the operating system. If you're on a Windows workstation, Windows will request an IP address after half the lease time expires. So after 12 hours, the workstation will re-ask for its IP address. Something interesting about that lease time is if we have too many devices on our network and too few IP addresses. So let's say that we have 250 devices on our network and we have 240 IP addresses available to hand out. Well, in that particular scenario, we don't have enough IP addresses to hand out to all of our workstations. What we have to hope for is that some of our workstations, at least 10 of them, are off at any given time. Well, when that happens, what you end up having to do is you end up having to turn down your lease time to a very, 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 very short period of time so that you're constantly refreshing the IP addresses in your lease pool. So if you don't have enough IP addresses in your lease pool to hand out to your clients, you have to make that lease time very, very short. Now, I was actually in an environment where this happened. We had added a few labs to our environment, and after adding the few labs to our environment, it ended up creating more hosts on our network than we had addresses available. So some of the devices weren't working. So what we had to do is we didn't have any more IP addresses available, or at least the current network administrator that we had working didn't know how to make that happen. So what we did instead was we turned the lease time down to about 2 minutes. When you turn the lease time down to 2 minutes, a Windows workstation will re-request its IP address every 60 seconds, which means that this process of sending out a broadcast message will happen every 60 seconds of every device that you have. Well, what actually ended up happening in this particular scenario is that the whole network crashed because there were too many broadcast messages because all the devices kept asking for IP addresses. So instead of having just a few short IP addresses where a few devices couldn't communicate, we changed our lease timer, and that ended up creating a situation where none of the devices could work because we had what's called a broadcast storm. Everybody's broadcasting messages all at once. We couldn't communicate anymore. So what we ended up doing actually was increasing the number of IP addresses available and increasing the lease time. My point to that whole story is that messing with this lease time down here can have dire consequences. If it's too long, your workstation's devices will hold on to IP addresses longer than they need to. If it's too short, they're going to request IP addresses too often, which could crash your network. So you have to find a very nice sweet spot for your DHCP server to operate correctly. Okay, let's take a look at the next piece of this.